Hello, everybody, and welcome back. I hope you guys are all doing well. We are wrapping up this unit's content by talking about something called Le Chatelier's principle. And that Le Chatelier, he was a French chemist, and we're just going to talk about some of the effects of different factors on equilibrium today. So today's lesson, we are just continuing talking about equilibrium in chemical reactions, and specifically which way chemical reactions will shift if different factors are changed. So let's take a look at what this principle even states. So it says if one or more factors that affect an equilibrium is changed, the position of the equilibrium shifts in the direction that reduces or opposes the change. So what does this mean? It means basically that if you're going to be, maintain a equilibrium, maintain a balance in a chemical reaction, and you start, let's say, increasing the concentration of your reactants. So you're throwing your equilibrium off because you have more reactants than you have products. So what's going to happen is that your system is going to shift to create more products so that you can even out your reactants with your products. Basically, it's just shifting to oppose the change that's taking place so that you maintain your equilibrium. So let's take a look at what happens if we manipulate concentration of both our reactants and our products. So remember, concentration is just how much of something there is. So when we're talking about concentration in chemical reactions, you're talking about the concentration of the compounds that are in the chemical reaction. So if we have our reactants increasing, meaning that we have more reactants added to the reaction, the system's not in equilibrium, right? Because you're off balance because you have more reactants than you have products. So when this happens, your equilibrium is going to shift to the right. Now remember, your reactants are on the left side of the equation and your products are on the right. So if we increase the concentration of our reactants on the left, our equilibrium is going to shift to the products on the right. So it's going to shift to making more products than reactants to try to balance out the equation. So more products are formed until the equilibrium is restored. Okay? So now let's look on the other hand. So what happens if we have an increase in our products? So we've got a higher concentration of products now on our right side than we do of reactants on our left. So again, Le Chatelier's principle is basically saying that our shift will occur in the direction that opposes the change. So if we have our products increasing, again, our system is not in equilibrium. So our equilibrium is going to shift to the left. That means more reactants are going to be formed until equilibrium is restored. And remember, when we're talking about these equilibrium equations, equilibrium reactions, there are forward and there are reverse reactions. If you have no idea what I'm talking about, that means you've gone too far ahead in your lessons and you need to go back and take a look at that equilibrium lesson. Okay. So let's take a look at an example. We've got hydrogen, carbon dioxide, and then those are the reactants, and then our products that are coming out are water and carbon monoxide. Okay, so let's think about what happens to the position, to the equilibrium, if number one, water is removed. So let's take a look. Water is one of our products. So let's say we are decreasing the concentration of our products, okay? So if we have a decreasing concentration of our products on the right, that means we're gonna have more reactants on the left. So if we remove water from this equilibrium equation, we're gonna have an imbalance. We're gonna have more of the reactants on the left than we do of the products on the right. So this particular equation, if water is removed, is going to shift to the right because it's going to prompt more water to be formed if water is removed in order to maintain equilibrium. Now, what is going to happen if carbon dioxide is added? So if we increase the concentration of one of our reactants, so carbon dioxide is one of our reactants, so we're going to have, again, a higher concentration of products on our reactants on our left than we do of products on our right. And so just like when we decreased our concentration of water in our first example, if we are adding carbon dioxide, we have more reactants than we have products. So it's going to prompt the system to shift to the right, meaning that more products are going to be formed until equilibrium is reached again. And finally, what happens if carbon monoxide is added? So carbon monoxide is now one of our products on the right-hand side. So if we add carbon monoxide, we're increasing the concentration of our products. So now we have more products than we have reactants. And remember, this is a equilibrium reaction, so you have forward and reverse reactions. So we can go from our products to our reactants. And if we increase our concentration of carbon monoxide, we're going to have an unequal portion of reactants to products. So now we'll have more products on the right than we do reactants on the left. And so if we were to increase the carbon monoxide, we would shift to the left. Okay, so does this make sense? So no matter what it is we're talking about, whether it's concentration or temperature, we're going to shift in the direction that opposes the change. So we're going to go in the opposite way of where the change is taking place. Okay, so that's concentration. Now let's look at temperature. We already know that temperature can affect reaction rates, so let's take a look at how temperature can affect equilibrium. So an increase in the temperature of surroundings, the reaction will go in the direction that opposes the increase in temperature. So it's going to go in the direction that will cool the surroundings. Okay, so it's going to go in the direction that will cool the surroundings. So if we take a look at exothermic reactions, the equilibrium will shift to the left. Now let's stop and think about that for a minute. In an exothermic reaction, your heat is released as a product. Okay, so heat would be on the right side of the equation. Okay, so if heat is on the right side of the equation and we're having an increase of temperature, that means your heat on your right side is increasing. That means if you want to think of it in terms of concentration, your heat concentration is increasing on your product side. Okay, we are shifting in the direction that opposes the change. So if it's an exothermic reaction, you have more heat that's being released on the right-hand side of your products. We're going to shift in the direction that opposes that, so we're going to shift it to the left. Now, in an endothermic reaction, the equilibrium will be shifted to the right. Now, why is that? Because endothermic reactions, you take heat in. So your heat would be on the left-hand side. You would treat heat as a reactant, okay? So if heat is increasing on the left-hand side, you're going to shift in the opposing direction. So you're going to shift to the right to favor the products, okay? So it's really favoring the direction that's going to cool the surroundings, but if you can think of it in terms of concentration, that can help, okay? So that's what happens if you increase your temperature. What happens if you decrease? So again, even if we're decreasing, you're going to go in the direction that opposes the decrease. So in this instance, you're going to go in the direction that will heat up the surroundings, okay? So in an exothermic reaction, your forward reaction is favored. Why is the forward favored? Because, again, in an exothermic, heat is being released. If you're seeing a decrease in temperature, you're going to want to shift into the direction that will cause more heat, right? So if in an exothermic reaction, heat is being released, it's heating up the surroundings, you're going to want to go in favor of the reaction that will release more heat to warm up the surroundings. So in an exothermic reaction, if there's a decrease in temperature, the forward reaction will be favored. So that means the products will be favored. And in an endothermic reaction, where heat is taken in, the reverse reaction will be favored. So the formation of the reactants will be favored because, again, in an endothermic reaction, heat is a reactant. So heat goes into the equation, and if you're decreasing your temperature, you want to go into the direction that will heat up the surroundings, so you're moving in reverse, so you're going from right to left. The last thing we're going to look at in terms of Le Chatelier's principle is going to be the effect of pressure. So with increasing pressure, molecules do move closer together. So if you think about compressing something or adding pressure to something, you kind of make whatever substance you have smaller. You're forcing those molecules to be closer together. So the position of the equilibrium will shift to minimize that increase. Okay, so we're going to shift in the direction of the fewest gas molecules, right? So you're going to shift in the direction of the fewest gas molecules if there is an increase in pressure, all right? Now, if there's a decrease in pressure, the molecules move further apart, so they have more room to bounce around. And then the position of the equilibrium will shift to increase the number of gas molecules. So in this instance, you're going to shift in the direction of the greatest amount of gas molecules. Okay, and how do we see the amount? We'll go based on moles. Okay, so if there is an equal number of gas molecules, the position of equilibrium does not change, so there's no shift, right? So if you already maintain equilibrium on both sides of the reaction, there's no reason to shift anywhere, okay? If there are gases and liquids or solids, only the gas molecules will count in the shift, okay? If we're looking at the effect of pressure on gas, only the gas molecules are going to count in that shift, okay? So I know this is a lot in terms of keeping it all straight in your head, because it probably does seem a little confusing right now. We're going to do a virtual lab today, so I hope maybe it'll help you visualize it a little bit better. But if you have any questions, let me know. I'm going to post a video doing some example problems with this. Really the thing to keep in mind with Le Chatelier's principle is that you're just shifting in the direction that opposes the change. Okay, so you're shifting in the direction that will make the equilibrium equal again, if that makes sense. Okay, so any questions, make sure you reach out, ask me via Remind or email, or set up a tutoring time. I'm going to post a video like I have been this week with just some review problems that we do together, so that'll help. And then I'll also post a video kind of guiding you through the virtual lab that you're going to do for this particular assignment. So if you have any questions, let me know. If not, I hope you guys have a great day.